As we look at our Chapter 8 topic, we're doing confidence intervals. We're trying to estimate with confidence. And I'll put this out here real quickly. We're focusing in on, working with, and I'm just going to write this at the very top. We're mainly focusing in on Chapter 8 on working with, proportions. And the reason is because a lot of times we do proportions when we're dealing with categorical data. All right, it's when we're doing things of, we're doing situations where they do a survey on, are you happy with the economy? Yes or no? All right. So we get a certain percent of the surveyors are happy with it, and a certain percentage are not happy with it. So that's where, when we look at our unit right now for the next 2 weeks, we're dealing with more categorical data. That's why we're dealing with stuff with proportions. So we don't have each individual data piece for us to be able to calculate a mean or a standard deviation in that standpoint, like we did with some of the other stuff. Now we do that, but we kind of, we mainly focus on categorical stuff. So so when we look at what is a point estimate is a single number. It is derived from a sample statistic. Derived from a sample statistic. To estimate a population parameter. Now that is, I spelled that wrong, parameter. So now that's just the general statement about what is a point estimate. Our point estimate can be anything from being p hat, which is a sample proportion. It could be x bar for a sample mean, which will be after spring break and those topics. It could be standard deviation. It could be, in like this first example, it could be median. There's anything that could be a point estimate. Any statistic could be classified as a point estimate. We're going to mainly focus on two point estimates. It's either p hat for the population or the sample proportion, or we're dealing with x bar for a sample mean. So in the following example here, they ask us, in each of the following settings, determine the point estimator you would use and calculate the value of the point estimate. So here, the first example says the makers of a new golf ball want to estimate the median distance the new golf ball will travel when hit by a mechanical driver. They select a random sample of 10 balls and measure the distance each ball travels after being hit by a mechanical driver. Here are the distance. So what is the point estimate? So the point estimate in this case, again, they nicely bolded it for us. It's the median. It is the median is what our point estimate is. So we would want to go out and calculate what is the median. What are our options for calculating the median? What could I do? You got two options in front of you. We don't add. We do add in this case because there's an even number. Remember, median is the number that's in the middle, so we always got to put them in order from least to greatest. Find the middle. There's an even number term, so in this case I would have to add and divide by 2. But if I list them in order, I think it goes 282, then 284, and then 3 285s. And then, there's 284s. Sorry, there's 2 of the 284s. There we go. So let me squeeze an extra one in there. 284, 282. Squeeze an extra one in there. And then we go 286. How many times is that? Once. 286, 287, 288, and 290. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there are 10 items there. So in the dead center of the middle, that would be right here. Because again, there's an even number, so those are the two in the middle. So I would add and divide by 2, and we realize that, hey, that's the same number. Okay. Now I need to find what is the, then we go on to the next one. The golf ball manufacturer would like to investigate the variability. So variability, we could use standard deviation, we could use range, we could use ISQR, we could use variance is what we could be on that one. So they asked us to find the IQR, so our point estimate is going to be the IQR. And then now we got to figure out, okay, what is the IQR? So what is it? So what is the IQR? What is IQR? Now this one would be, we got to find out, well, what is Q3 minus Q1? And so the answer is 3. It's 287 minus 284. Now I would personally go through and probably type all those numbers and do a 1var stat and let it calculate what those are for me, is what I would have done instead of listing them by hand. But doing those 10 items is not that hard. But I would recommend doing a 1var stat here and getting what your median, your Q1 and Q3 are from there, is what I would recommend to do. The math department wants to know the proportion of students who own a graphing calculator. So it takes a simple random sample of 100 students and find that 28 own their own graphing calculator. So again, it's a proportion of a sample. So what statistical symbol should I use for my point estimate? What symbol is used for the sample of a proportion? Okay, that's not good. P hat. P hat is that is my sample proportion. That is my sample proportion. Again, P typically stands for proportion in statistics. P with the hat on it deals with it is when I'm doing a sample. If I just use a P, that indicates the population. So in this case, okay, what is P hat? P hat is 28 over 100, which is 0.28. Remember, we kind of list it as a decimal, as a proportion. Again, we mainly focus on working with all this confidence interval stuff for right now, with proportions and mean. Other courses will use some of the other values, but we mainly focus for AP on either doing sample proportion or sample mean. A confidence interval. Since our point estimate is probably not exactly, but somewhere close to the true parameter, we can estimate an interval that we are pretty confident the true parameter lies in. Okay, again, my sample of this last example here, they did a sample of 100 kids, and 28 have had calculators. So the sample proportion was 28%. And if we said, okay, does 28% accurately represent the number of high school students at Beach High School that have a graphing calculator? I don't know. But a confidence interval, when I compute it, will give me the range of roughly what the true proportion of students at Beach High School who have a graphing calculator on the road. Okay, it should be contained in that confidence interval. Okay, we know it may not be exactly 28% because we got 1,400 students in the school. So for it to come out and us survey all 1,400 and then get it, it's going to be pretty, it really won't work out that exactly that number has it, but it should be pretty darn close to it when we figure out how many actually have their own. It could be a lot less, or it could be, more. So it's one way or the other. The interval, as we look at this, is called the confidence interval. The amount of confidence we have in the interval is called the confidence level. And we're going to have to interpret a confidence interval and the confidence level. We have some script for that. Confidence level. The confidence interval consists of, this is how it's structurally made up in just words. It is consisted of the point estimate plus or minus, so plus or minus sign, and then what we call the margin of error. That is the generic format, and just using words, not using symbols. Now that format is on that cheat sheet guide. Okay, so when you go back and you look at, like I'll go back real quickly here to show you, and I go to handouts and our statistic form. Mr. Stevens, find it. There we go. There we go. There's our confidence interval. Okay, so there's our confidence right there. It's basically our statistic, and technically these two things together make our margin of error. And we're going to talk about this more, all right? But again, the generic format is on that guide they give us for the AP test, okay? They may not give the symbols, so that's why we got to know, okay, really what makes up in generic words each of those parts. And again, we'll talk about critical values in a minute and what the standard error of the statistic is. A lot more really tomorrow is what's more tomorrow's lessons based off of. The margin of error tells us how close the estimate tends to be to the parameters. In repeated random sampling. So this is where we typically see, like on the news for voting and stuff, that as they do polls and we say that, hey, this percent are in favor of the economy plus or minus 2%. So that plus or minus 2% is the margin of error. Okay, so even if they say, hey, 48% of the Americans are in favor of the economy at this moment, plus or minus 2%, then that means that the true proportion of Americans that are approving of the economy are anywhere from 46% to 50% is what that's telling us, and that's our confidence interval. The confidence level gives the overall success rate of the method for calculating the confidence interval. So in C% of all possible samples, the method would yield an interval that captures the true population, the true parameter. So whatever the true parameter is. So I get a better. All right. Now, confidence level doesn't tell us the chance that a particular confidence interval captures the population proportion parameter. It tells us how likely. It tells us how likely the method we are using will produce an interval. I got to put that down here. An interval that includes the parameter if we use it many times. All right, so sorry for the squeeze of it. So with that in mind, when we're looking at interpretations of stuff, we want to steer away from saying that, let's say my confidence interval, our confidence level is like 98%. We do not want to say that there's a 98% chance that this interval contains the parameter, okay? So it doesn't refer to the percent chance of it happening, okay? that's what that's kind of telling us about is it does not tell us the chance that it would capture it. It tells us how likely if we repeat this multiple times, really let's say I do 98% of the time that I repeat this process over and over again, 98% of the time, those intervals are going to capture the true parameter, is what it's doing. It's not the chance of it happening. It's there's 98% of the time we will contain or capture that true parameter. So I got a couple scripts here that we get to use for interpreting. I'll give it a moment. You still writing?
What is that? The A?
What, on the second line?
Yeah.
It says and. And then a squiggly because I couldn't squeeze interval in there.
No, on the second part. Parameter if we use.
Parameter if we use it many times. That's an I. That's an I would slide up to the T by cursive. Sorry. I'm one of those freaky people that print in cursive at the same time. You just said mid-sentence and mid-word. So it's bad. I mean, it's really bad when you do that. I mean, it's supposed to mean something like psychologically wrong with you and stuff. So I don't know. But I think it's just the ADD part and stuff. It's just, you just kind of get a little distracted. And you start printing, and then all of a sudden you're like, I want to go faster, so let me do cursive and stuff. So it's the brain just not being focused. Anybody need that any longer? I know I was writing fast and talking fast as we're doing things. So again, we're going to get into interpreting the confidence interval and the confidence level. So there's two separate scripts. Again, this is where we talk about note cards, flashcards, where we have little flashcards to kind of refer back to for scripting that make it easier to remember. Did you notice on Achieve that I actually put the flashcards out there for each of the chapters? Yeah. After we talked about it like 2 or 3 chapters ago, is I went through and put all the flashcards out there for the whole semester underneath the assignments. There should be something that, and we'll have to figure out on your side how you see it. But it actually has out there like chapter 1 flashcards. I did them in English. I figured Spanish wouldn't help, so I did the English version. When we get done, I'll show you, because there's actually, as we look at our review process, as we get in that in April, there's also some activities like where we can do some things, little games, not just quizzes, but we can do some Quizlets and little stuff on there. So I'll show you a little bit later. We'll see if we can find it for you guys on your version of Achieve. So, all right, skipping on to the next part. As we look at interpreting our confidence intervals, we got 2 scripts here. And I bet I put a big old Dallas Cowboys blue and white star up there. My fraternity brother would be happy that I used that. He would notice it real quickly. It was Dallas Cowboys. So the first one is the confidence level. So the first script that we see up here, this is the confidence level. So this is the confidence level interpretation. We would start off saying that whatever percent of all possible samples of a given size, so we want to make sure we specify the size. So if they tell us that it's size 10 or size 50, we want to specify what it is. So it's like 98% of all possible samples of size 10 from this population will result in an interval that captures the whatever our parameter is. Okay? And then for describing the confidence interval, that's the second script. So the confidence interval, we would start off by saying we are 95% confident that the interval from, and then we'd specify the values from this decimal to this decimal captures the actual value or the true parameter of blah, 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 blah. Okay, and again, we're going to practice doing those here in a second. To the left is a sampling distribution where they repeated the confidence interval process multiple times, is what they did. And they indicated basically, okay, where is the mean of the sampling distribution? It's the dead center. And in this case here with the confidence intervals, as each one of these was an individual confidence interval. Okay, each one of these was an individual confidence interval. where they did a random sample, okay? And so, like this first one, it happened to be really close to the mean. The second set of doing the process, their proportion or p hat or whatever it is was a little bit above the true mean. And then the next one was a little bit more above. Then it got a little bit closer. This one was way above, and so their confidence interval as a whole did not capture the mean. Whereas in each of these other cases, it didn't matter that the red dots wasn't on the black line. Did the green line, which represents the whole confidence interval, did it capture the mean or the p hat or whatever it is, the parameter in there? And so, again, we could figure out, what confidence interval does by adding up how many examples were there and so forth, and we get to do that later on. So, as long as the confidence interval captures the true mean, then that's why we're saying it's in between there. So here we get to practice a couple examples of interpreting the confidence interval and level. How does the fat content of brand X hot dogs vary? To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation. So that lets me know when I talk about what point estimate do I need to say in my interpretation. I need to make sure I talk about the standard deviation is what I need to refer to. And they tell us that the confidence interval is from 2.48, so 2.84, comma 7.55. All right. So we're going to take this and we're going to interpret the confidence interval for the first part. So here, using our script up above, the one right above us in yellow, we would say as follows. We are 95% confident that the interval from 2.84 TO 7.55 captures the true population standard deviation of fat content of brand X hot dogs. All right. I'm going to pause and let you guys write that down. Okay. So again, all I did was use the script that they gave me. I like always starting with this way because that's the most common way that they do stuff. We are whatever percent confident that the interval, we state what the interval is, capture the true population, and then we would say standard deviation. Again, as we progress through this chapter, it's going to be mainly proportion, is what we're going to say, the true population proportion. And then we talk about what what was our variable that we were talking about. In this case, it was fat content of brand X hot dogs. Okay, we do not reference the sample size in this one. We're going to reference it in the next one. So again, whenever you're doing the confidence level, you want to make sure that you reference sample size. We always want to make sure when we're interpreting the confidence level, we reference the sample size of sample size this, of, and so forth, okay? So here's an interpretation for the confidence level. 95% of all possible samples of size 10 will result in an interval that captures the actual standard deviation. And again, it would be okay to put on their actual population standard deviation because we are talking about the parameter. So we could put the word population in front of, between the words actual and standard. We can put the word population there. Because again, we are talking about the parameters. So saying population standard deviation is okay. Again, confidence level. We always reference back to this. If we repeat this with the sample size, if we repeat many sample sizes of this, 95 in this case, 95% of them will capture it. Okay. You'll hear me fluctuate between the words contain and captures when I write those statements. Either one's fine. Okay. Just like if we go back to chapter 3 when we did linear regression, it was okay to say predicted y value, like the predicted amount, and we could have used the word expected, and those would have been okay to use as synonyms in the topics for explanations and stuff. So I try to stick with predicted in that topic. Here I fluctuate between contains and captures. Is what I fluctuate between. Any questions so far? All right, so next one. True or false? The interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation. Is that true or is that false? It is false, correct? All right, because remember, the confidence, the 95% doesn't tell us the chance that it's going to happen. It just tells us that when we repeat this multiple times, 95% of those that will capture that true population standard deviation. Okay, so 95% of those samples are going to contain it. So we would say false, okay, is what we would say here. We would say false. Again, 95% of the intervals are accurate and contain the population standard deviation. Okay, so again, knowing that fact that, hey, I stay away from the terminology 95% chance helps me on those multiple choice questions. Okay, that's what it helps me on the AP exam. It helps me on those multiple choice questions where when I see it's talking about confidence intervals and they're saying, hey, there's a 95% chance it's going to contain it. We cross those off right away. Okay, we always look for those clues on when can I eliminate answer choices. Okay, and so that's one of the ones that we look for. Constructing a confidence level or interval, sorry. Here's the challenge. There is a price we pay for greater confidence. What is better to have, an 80% confidence or a 99% confidence? 99, right? We think 99% confidence is better. The challenge is there's a price when we have a higher level of confidence. Okay? What happens is the price we pay for greater confidence is a wider interval. And so we have some characteristics on the next page to finish up the lesson on as as we change the confidence percentage, as we make it larger, what does that do for the interval size? Okay? And I always got to remember, we can always do the opposite. If we make the confidence level or percentage smaller, it does the opposite effect on the confidence interval. Okay? So we got to remember, as we look at these things, we can also do the reverse action. Because they'll ask us in stages, they'll say, how does going from a 99% confidence level to a 95% confidence level change the actual numbers? How does it change? Does it make them get closer together or make them get farther apart? That's what they end up asking us as little sidebar questions. Okay? And then we get to turn it into, later on, does that affect our decision in a hypothesis testing situation as we change that part? Okay? So we get to do a lot of connections going forward. So here are some little statistics as we go forward here. So again, just to recap, when we're looking at calculating a confidence level interval, it's the statistic plus or minus the margin of error. Now, a little bit more specific, again, this next one is what we see, as I highlighted and underlined it in green. This is what we see on the AP reference sheet. So tomorrow we get to break it down a little bit more, but this is when we look at our chapter we're in right now. It's going to be p hat plus or minus, and then we have a critical value, which I'm just going to put down as z star. And then we have our standard deviation of the statistics. So it's actually a square root of something. Okay, there's a square root of a fraction. So tomorrow I'll fill in some of those other parts, but the statistic is the p hat. The critical value is our z star. It is basically, in a way, nutshell, it's a z-score. Okay, so we're going to talk about z-scores again as we do certain things. And then we have times the standard deviation of the statistic, which is also known as the standard error. Okay, so sometimes depending on the material you'll reference, this little part right here is also known as the standard error. That's also known as the standard error. And that's what sometimes gets people at times when we see margin of error and standard error. Margin of error is the whole component of what's after the plus or minus symbol. The standard error is just the standard deviation of the statistic, whatever you're working with. Okay, so they are two different values. You need the standard error to help calculate the margin of error. So a critical value depends on both the confidence level C. Let's go with and the sampling distribution of the statistic. So again, our critical value depends on, one, what is our confidence level? Is it a 98%? Is it a 95%? Is it a 75%? What is our confidence level? And also the sampling distribution of the statistic. The critical value is tied to the confidence level. Greater confidence requires a greater critical value. So that's telling us that, or that's basically associated with a 95% confidence interval or confidence level has a certain critical value associated with it all the time. A 98% confidence level has a different critical value, and that critical value is bigger because we increase confidence level, therefore the critical value increased. That's what that statement's referring to. All right, so again, when we look at it more in depth tomorrow with numbers, it's going to make a little bit more sense. Standard deviation of the statistic depends on the sample size n. So again, the last part, this little part here where I have it under the square root symbol, that's what that's talking about. That depends on the sample size n. Larger samples, more precise estimates, which means less variability. Again, you think back to our sampling distributions as we went from a sample size of 10 to a sample size of 30 to a sample size of 100 to a sample size of 1,000, and we repeated it multiple times. We noticed that our distribution got more normal, more bell-shaped, but it also had less variability. They weren't as wide, they weren't as spread out. Okay, so that's what this was talking about is as we get a bigger sample size, then we get a better estimate because there's less variability. Okay, or if we looked at a picture graphically, we would see it be a lot more, tighter together as a histogram to be in bell shape and so forth. Okay, so smaller sample size, more variability. Okay. Therefore, margin of error gets smaller. Margin of error gets smaller when confidence level decreases. So when I go from a 98% confidence interval to a 95, my margin of error gets smaller. When I go to a 90, it gets even more smaller. Margin of error also gets smaller when the sample size increases. Now the challenge is, it's more costly to do bigger sample sizes. It's more time consuming to do bigger sample sizes. Okay, so that's why sometimes we can't do sample sizes of 1,000 every sample because it takes too much time. And so we work with the smaller numbers, but there's a price to pay. Okay, now this is where I was referencing back to the opposite type of stuff. If we go from a smaller confidence interval to a bigger confidence interval, so I go from a 90 to a 97, then my confidence level, my margin of error increases. So if I go from 90 to 97 in the confidence level, my margin of error gets bigger. Okay? If we go small, as this decreases, as the margin of error gets smaller when the confidence level decreases. If I go to a smaller sample size, so go from 100 to 20, then my margin of error will get bigger. And the reason goes back to what's inside the square root. I'll put it on the thing there, but again, we'll talk about it more tomorrow. Underneath the bottom of that fraction is my n. My sample size is in the bottom of the fraction. Just like we had it in the last chapter when we were doing sampling distribution, we always had to, if it was means, we did the standard deviation divided by the square root of n. If it was the proportion part, in 7.2, we did the p hat times 1 minus p hat divided by n, and then we square rooted it all. So, as n gets smaller, so I go from 100 to 10, then that means that gets to be a bigger number as a whole. Because I'm taking the top and dividing it by a smaller number. That is bigger than what the opposite. So that's why it increases. So, and let's see what else. Almost done. Conditions for constructing a confidence interval. First, we have to look at, does the data come from, is it random? Data should come from a well-designed random sample. Again, this is where we're looking for, as they state what's happening. Come from a well-designed random sample or randomized experiment. And if we do not, if we as we're going to look at constructing a confidence interval, and it doesn't tell us that there was a random sample taking place like an SRS, or they did a randomized experiment where they randomized how people were assigned to the treatments and those type of things, then we should not infer to the greater population. Okay? And we cannot do a cause and effect. All right? We can do the calculation, but it's just not, it doesn't help us if we're just spinning in mud. There's no good to do it. Because we can't do any inferring from it if we don't have a random sample, and if we don't do a randomized experiment. Which is that chapter 4 stuff. Okay? Normal. Are we normal? So when we're doing our confidence interval, if we meet the random clause, great. Normal clause. Is the sampling distribution of a statistic, is it approximately normal? So if they come about and tell us that it is approximately normal, then we don't have to worry about approximately normal. If they tell us that our stuff, our distribution was approximately normal, then, and they don't tell us like the sample sizes and that type of stuff, then we don't have to worry about it. If they use the phrasing approximately normal, then I meet that normal clause. If they don't say it's approximately normal, but then they give us, okay, I have a sample size of 20. All right. Well, we think about last chapter, there's a cutoff for when we're dealing with means for a sample size for it to be normal. 30 was the cutoff. Okay, so we're going to bring those things here in a second here. So if they tell us that it's approximately normal, but don't give us any information about the sample size, that's okay. We can go ahead and say that it's normal. When we're dealing with proportions, the normal condition is when n times p is greater than or equal to 10, or n times 1 minus p is greater than or equal to 10. And in this case, it's going to be p hat. And that's what we're going to see tomorrow. Is again, as we're doing this stuff for our confidence intervals, we're going to be using that same clause we did last chapter and doing the n times p is greater than or equal to 10, and so forth. If I'm dealing with means, which is after spring break, normal condition for means if the population is normal or the sample is sufficiently large, which was means greater than or equal to 30. If I'm greater than or equal to 30, then I get to go ahead and say, hey, I'm sufficiently large enough, it's normal. If I have a sample size of 22, is 22 bigger than 30? No. But if they tell me that it's approximately normal and my sample size is 22, I'm okay to go ahead and do it. Okay? When we get into chi-squared stuff later on, there's some extra stipulations. And actually, even in the after spring break with the means, there's a couple extra stipulations when it's a lot smaller than 22, when it's in the teens or below. There's some other stipulations we have to look at. Let's see, independent. It's independent. Sampling with replacement for the population allows us to use standard deviation formulas, or if sampling without replacement. If we meet the 10%, if we meet the independence clause. Again, we've been talking about these in independence, which was 10 times little n, is it less than or equal to capital N? So again, we have those conditions of random, normal, and independent, like we started doing over the last several chapters. If I meet all three of those things, then I can go ahead and compute my confidence interval. If I fail one of them, I got to stop. I can't do it. Okay? If you fail one, we stop. We don't do a confidence interval. So, must pass all three conditions to do the confidence interval. So I got to meet the random clause, normal clause, independent clause. And again, now we're going to start seeing that 4-step model for doing a free response come into play more. We're going to write that stuff down in the plan stage. We're going to go through, do our little statement, then in the plan phase, step 2, we're going to say we're going to do this type of a confidence interval for what, and then we get to say if conditions are met. And then we're going to write down random, and we're going to say, okay, did we meet that condition and how? All right. Then we'll say normal. We'll show the n times p hat, or we'll do the n is greater than 30. And then for independence, we'll do 10 times the sample size. Is it less than 10? Is it smaller than the population? And that's where we use that. It's reasonable to assume that there's, blah, 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 blah. Okay? So, again, if we fail one, we stop. Our methods assume, our methods of calculation assume a simple random sample, not a stratified or clustered sample. So as we do stuff, we know stratified and cluster samples were examples of a simple random sample that we had more specifically. However, we're not going to be doing calculations based off of that material. We're just doing it off the general simple random sample where they assigned everybody a number. And then use some type of technology to pick who was going to be part of what's going on. Or they did the table of digits. Okay, so we're mainly just doing the generic simple random sample, not the more specific cluster and stratified ones that we talked about in chapter 4. The margin of error is only accurate if we survey or experiment is well done. Okay, margin of error is only accurate if the survey or experiment is well done. If it's not well done, then under coverage and non-response in a sample survey can lead to additional errors. So, again, as we look at this section, it's more of the characteristics of being able to do it, do some interpreting of the confidence intervals and the confidence levels. Tomorrow we actually get into the physical calculation of doing a one